Greetings for those of you just joining us. Good morning, good afternoon, good evening, and late into the evening in some cases. But we'll be getting started in just a few minutes. We're giving people a minute or two more to join in. But we have an excellent webinar for you this morning, and we'll get started in just a moment. While we're waiting, you'll hear it a few times, I'm sure, but we're excited to have our preliminary program on our website. Many of you may have received it in an email, but we're putting together a really outstanding program for you in the October conference in Providence, Rhode Island. So if you haven't already, go find the preliminary program. I think you're going to find some really interesting papers and topics on a lot of industry trends and innovations going on. Well, why don't we go ahead and get started? Again, greetings. We have a wide international audience, so from wherever you are, I know some of you are joining us late into the night, and we appreciate that, but also in the afternoon hours on a Friday. So hopefully this will lead into a nice weekend. My name is Dave Cadu, and I'm the CEO of IWCS, and I'll be your moderator for today's webinar event. A few housekeeping items. Please note that as an attendee, you're part of a larger audience. So during the presentation, you will be in listen-only mode. But also, please note that the webinar is being recorded and will be posted on YouTube and linked to our IWCS website. So you can share that with your colleagues or go back and revisit it at your convenience. So again, with that, if you have any questions during the presentation, please enter them in the chat panel. It should be on the right of your screen. After typing your questions in the space at the bottom, please be sure to hit the send button, and your questions will be addressed, time permitting, at the end of the presentation. Our IWCS webinar series event is hosted by our Cable and Connectivity Industry Forum, and you'll be seeing more about that at the end of the presentation. Today we welcome Ron Tellis, who is a subject matter expert at Belden. He's located in Florida, USA. Ron will be presenting his paper on cabling for fault-managed power systems. What is Class 4? Very topical innovation being introduced into our market. Ron is a subject matter expert in RF design and electromagnetic propagation, and he joined Belden in 2016 to help define the roadmap of technology and applications in the smart building and data center applications. He represents Belden in the ISO WG3 committee, as well as the TIA TR42 premise cabling standards, the IEEE 802.3 Ethernet working group, and is a committee member of the NFPA 70 National Electrical Code, making panel 3 and 16. Ron is the innovator of 16 patents, and he has a Bachelor's of Science degree in electrical engineering from Purdue University and a Master's of Science degree in electrical engineering from the Illinois Institute of Technology, and has a Master of Business Administration also from Purdue University in Indiana, USA. So we welcome Ron. We really appreciate your contributions to our industry, and take it away.
Thank you, Dave. Thank you for giving me a chance to present this. I know that this paper was presented back last October. Unfortunately, I wasn't able to present it due to personal reasons, but I'm glad to be able to be here today to do the same. I did update this a bit and got a little bit more into the use cases, so it's slightly different, but it's all it's very minorly changed at the end. But I did update it with the latest on the NEC code. So let's get started. This is my artistic approach at what if somebody asked me what fault managed power was, I would give them this picture and say, 1,000 words. It's a lot of power being able to be distributed in a safe way, and it's finding many different applications. So let's get into that a little bit. So we're going to start out with the different ways to remote power, talk a bit about DC and PoE, which we've already known about, and then also get into the FMPS, fault managed power systems. I'll give you an update on where we're at in the National Electric Code. This is called Class 4. Some people may think that it's digital electricity, which it is, but that's for one vendor. Volt Server created that, but there's other vendors of fault managed power on the market, and the NEC thought that we should give it a classification. So it's called Class 4 fault managed power in the standards that allows for other vendors to be a part of this, and they are other vendors of fault managed power systems, but they're all kind of synonymous in that way. Then we'll talk about the cables that go along with that and the certifications. I'll give you some examples and use cases, and then at the end we'll have some time for questions and answers. So when I think of remote powering delivery, I think of the three ways that we do it within communication systems. The first one's been around for ages. It's the DC line power. Depending on the gauge size and how much voltage drop you're going to allow over those cables, that distance can vary greatly, and it's really engineered. But let's call it 200 to 300 meters to be practical. But we are limited to 100 watts because at the source power, these are called limited power supplies. So that means that the source is limited to 100 watts, and that's class 2. Class 2 also describes power over Ethernet. This is where we're using category cabling to deliver power and data over the same cable. We have typically always said that's 100 meters, but the reason that's been 100 meters is because 100 meters was a convenient number to keep structured cabling within for TIA purposes, so that as we evolve from one to the next, we didn't go beyond what one application could over the other. But the practical standpoint is that there is no limitation other than the insertion loss and DC resistance limits that are set by the people making the applications, which is the IEEE. So if you just look at the application limits, we can take data cabling when we lower the data rates. We can take that 250 meters on 22 gauge wire, and we'll talk about that. But again, we're limited to 100 watts at the source, so that's the definition class 2. Then we have this technology that's come on board. It's gaining a lot of steam within a lot of use cases within the NEC and other factions. We call it felt managed power, and this is giving us the ability to do either or. Okay, you can't do both. You can either go a long distance, thousands of meters, 2 kilometers is usually a good touch point, or we can deliver high power, thousands of watts. So I've always kind of, in a nutshell, said it's either 2 kilometers or 2 kilowatts, somewhere in between that. So moving on, let's get a little bit more into DC line power. So this is the traditional way that telecommunications has done it for many years. It's the negative 48 volt line that's been around and is being adapted to use in other applications. And again, the source power is limited to 100 watts. And then if you design a certain voltage drop, that meaning how much power do you want to have delivered to the end, how efficient do you want to be, and what gauge size, those all go into this reach limitation. So if I wanted to only allow 10% voltage drop to deliver 90 watts at the end with 16 gauge, then I have a reach of 123 meters. Usually, when we're talking remote power in communication systems, we also have to deliver data since this is a DC line that's copper conductors, but it's quite often used with fiber to deliver the data portion. And our maximum speed with multimode fibers with these distances is 10 gigabits. And then single mode, we don't have that limitation. So, we can go hundreds of gigabits, which is well beyond any application that we normally see with remote powering applications. So next is PoE. The reason or the limitation on PoE is that the DC loop resistance has to be less than 25 ohms. That's a requirement out of the IEEE, and it's specified in the 802.3 standard. And that's overall temperature ranges, so we have to make sure that we're cognizant of that. The other thing to deliver power and data, you have to make sure you meet the link segment insertion loss. So that's where you can see on the right, if I lower the data speed, I can go further because I don't need that bandwidth needed out of the cable. So if the power source is limited to 90 watts, I know we've always kind of tongue-in-cheek called this 100 watts because but it's a little more flashy to call it a 100-watt application. So this is the BT standard, and the ultimate delivery is 71 watts at the end. So any device on the end of a 60 watts or 100-watt BT source is only going to deliver up to 71 watts. And then if I use my category 6A cabling, which is typically 23 gauge for the horizontal, with 10 gig, I'm limited to 100 meters, and that's so that we can meet the insertion loss over that 500 megahertz bandwidth. But as I go further down in speeds, 1 gigabits only needs 80 megahertz, and we go down to 10 megabits, we only need 16 megahertz of bandwidth out of that. And so that means that I have more headroom, and I can go further distance and still have that signal to noise ratio needed to keep my signal integrity. And that's why we can go beyond that. Now, it wouldn't be wise, in my opinion. I mean, it wouldn't be a good use of your money to use Cat 6A in that vein. So there are other cables on the market, which I'm calling application cabling, because it's not meeting the category. It's only working for certain applications. So if I was to use this 22 gauge cabling and go 215 meters, I can meet that 25 ohm loop resistance requirement and also the link segment insertion loss requirement and deliver 10 megabits, which is perfect for security applications or IP cameras with all the codec and compression that's out there nowadays. We're getting 4K UHD signals to our homes over this twisted pair, and that's because the codec is so great, and you really only need for 1080p, like 5 megabits of bandwidth. So that's why that's a very attractive offering. But we're here to talk about this new technology we're calling fault managed power. We've worked here at Belden very closely with Volt Server. We helped them define their systems into the standards, the UL 1400-1 and -2, and also supported its inclusion into the National Electric Code. So these numbers here are from Volt Server, so you'd have to look to your individual vendor for fault managed power to see what they can do. And these technologies are also advancing, and I'm finding out that these numbers can actually be increased with all the advancements that they're making. So, but I wanted to put this here to make sure that we, see in comparison, how does that stack up to the other power delivery methods? And at the end, during my use cases, I'll show you how all three of these delivery methods actually work together. So it's not one over the other. So if I was to remember I said it's either or. I can either send lots of power. So let's say I want to deliver 2 kilowatts of power over 4 pairs of 16 gauge wire. I can do that, but my limit's going to be 500 feet. And that's great for a lot of the DAS systems that we worked with VoltServer to install on several different stadiums. But let's say I wanted to only deliver 100 watts, but I want to go to some remote location to put a switch that only needs 100 watt, or an ONT that only needs 100 watt. I can do that, and I can go 2 kilometers away with that with one pair of 16 gauge. So that kind of gives you an idea of what the benefit is of this new technology. It's the ability to do high power or long reach. Now, again, since these are communication systems, we have to have data with it. And when we talk about the maximum data speed, a lot of these applications and this distances, multimode fiber is not going to cut it. I know someone's going to say yes, you can, and then I'm not going to argue with you. But it's going to require a little bit extra knowledge and understanding to engineer that type of solution. So I'm really saying that it's not really recommended. The best way to go, especially if you want to future-proof, never have to worry about that distance limitation, and you just run this along with a single mode fiber. So that's the comparison of the different remote powering applications. Let's get into the NEC definitions, and let's concentrate on just class 2 and class 4. Remember, DC line and also PoE are class 2. And the unique thing about class 2 and why we like it so much is that it provides safety. And these are the actual definitions out of the 2023 National Electric Code. And I'm underlining this. It provides safety from fire initiation standpoint and provides acceptable protections from electrical shock. And that's because it's a limited power supply. The source is limited to 100 watts. There's a certification, of course, but that's how we deem that safe. Now we go to class 4, and you say, "Hey, wait a minute! I'm doing a lot more than 100 watts." And you're right, you are. But it's a different technology, and what it's doing is there's a data link between the transceiver and the receiver, a class 4 transmitter and a class 4 receiver. They talk to each other very quickly. In fact, so quick that if something were to interrupt that connection, there would be a huge change in that link that's connecting those two pieces of equipment. It would immediately shut off before any damage could be done. So from that method, it's doing the same thing as class 2, but it's doing it a different way, and that's through managing any faults. So any fault that occurs on that line, that circuit that's connecting the transmitter to receiver, is being managed, and through that methodology, it's providing the same safety from a fire initiation standpoint, and provides acceptable protections from electrical shock. So this is where we say the phrase that class 4 is just as safe, if not safer, than class 2. And if you wanted to find out how it's safer, that's where that would be a different discussion, because now we're getting into the individual synchronicities of individual systems. But it is providing more protections than a GFCI or an AFCI can through this monitoring. So what does that mean from a cable standpoint? So if we look at the 4 different classes, class 1's, that's higher voltage. Let's just take that out of the equation. That's not what we're going to use for communication systems. That's used for more of remote signaling applications. Let's focus on 2, 3, and 4. And, look at the safety from fire initiation standpoint. Yes, 2, 3, and 4 have it. Does it provide acceptable protection from electric shock? Class 3 does not. So there has to be some extra provisions there to provide that safety factor. And going back to just looking at class 2 and 4, they both do. The listings, we have several cable listings. We have the CM versions, CM cables that are good for class 2 would be CL2, and then the riser would have an R on the end, P for plenum, and X for well, it's used for more of some outdoor usages. We look at the voltage rating. All of these cables do not have a voltage rating listed on the cable, and that's by design. If we were to do that, we know somebody would pick it up and say, "Oh, 300 volt rating, I can use this to do my lamp wire." All right, so on purpose, the NEC said we're not going to put the voltage rating on the jacketing, but if you go into the tech data sheets, the cables do. And class 2 at minimum needs 150 volts cable rating. Often those class 2 and 3 are dual rated, give you 300 volts. But then when we go to class 4, we have this higher voltage. And that means that there has to be extra provisions in the design of the cable to allow this. And it's usually through the change in material or thickness of material. And that has a voltage rating of 450 volts. Now, this is important to note. This number right here really tells you that you can't just use category cabling to do your fault managed power, and I highly encourage you not to because of that. We want to keep this safe, and within the electric code, we've set up that safety by making class 4 a unique requirement, and that you can't substitute 2 or 3 cabling, class 2 or class 3 cabling for class 4. You would actually have to have a dual rated class 3 and class 4 cable if you wanted to have that functionality. But the substitution, like you see with where you can use class 2 or class 3 for class 2 is still there, but you can't use class 4 for class 3. You have to have a dual rated cable for that. So just to re-emphasize that part, the devices and the cabling must be marked with its class listing. So here's a string example off of our class 4 cable. It's we call it digital electricity cable. It's the part number. It's 16 gauge, 8 pairs. It's unshielded. And then we have 8 pairs of 16. 16U, 8 pairs. So we have eight pairs within it, and it's CL4 rated, and the jacketing can handle 105 degrees C. It's sun and wet resistant, and then we included the CL3 on there as well in case there needs to be that substitution. So look for that CL4 to make sure that your CL4 system is properly set up. How are we doing on time? Okay, doing fine. So let's look at how is this being adopted. So if you go, there's a couple sources here: Electrical Safety Foundation link that's in this presentation. You can click, and this graphic on the left will pop up. Not sure where the graphic on the right pops up because I think it was taken down and replaced with words, but this is still valid. So this is up to the latest information off of these sites, and you can see that 2023 is the first code cycle that adopted class 4. So people in Minnesota and Michigan, Ohio, and so forth, they're starting to work on this, and I know that Minnesota is actually looking at training and certification for the installation of this class 4. But what about the rest of the world? What about people in Indiana, or what about people overseas? I don't even have Europe on here. We'll talk about that in a second. But we're not going to see all this happen overnight. The adoption of the code takes several cycles to happen. And there are provisions within the electrical code that if your local jurisdiction doesn't follow the latest, there are ways to there is a way in in the code to present that to the HJ so that they know that it's this is safe to use. I fail to remember what exactly the details of that, but I know that's in there under the section 90 somewhere. Moving along, so as mentioning, you know, what happens if we're overseas? You know, they're not using the National Electric Code. Some do. I'm not saying that it's not, but there's some that that don't. Well, some of the questions that come up: can I use? What if I'm outside North America? What if it's earlier? Can I use any FMPS? And what my answer to that is, you know, you got to work with the AHJ. Go to your supplier, manufacturer. Us will help you out. And there are there are some systems that do have certification to IEC 62368-1, and this is certified through a NERDL, which is qualified by OSHA, and this is the way to keep this technology valid in places that you know don't use the code. So there are ways to get this implemented if you don't follow the latest code. And again, we can help you out with that if needed. Let's talk about installation. So separation. How do you use this? Well, we have introduced this term limited energy cabling. This is it's just starting to take shape. I'm sure it could be subject to change, but it seems to be sticking. And this limited energy includes all category cabling, cable TVs, CATVs, low power broadband, optical fiber, power limited fire alarm. If we jump those all together and also fault managed power cables, class 4 cables, those are all considered to be limited energy and are treated the same. That means that they have to be separate from the mains. And the good thing it adds a bit of diversity here is that it's allowing you to use you know, cable traces as opposed to having everything within conduit. The certification of this is being thought about and being developed through many of the installation organizations, NSCA, CXC, NASCALA, and NECA. What they're trying to do is get all of the, you know, the what we've called low voltage installers into a classification of integrator, and that'll help raise the awareness that this is a large labor force and make sure that we have the right training for them to do this safely. That's the key here. And while that all happens, this is this fault managed power systems are going to be installed with close supervision with the manufacturers of that system. So it's an engineered solution. So I was asked when I first found out about digital electricity. I said, you know, tell me about it. And the gentleman from Volt Server, Bob Manifold, is you know, very outspoken person, and said, look, here's the here's the elevator speech. It's the 5 S's. Okay, it's the safe delivery of significant power over significant distance using smaller conductors, providing speedy deployment. So that, in a nutshell, kind of supports that my little graphic there. So in really what fault managed power allows you to do is it allows system components to be placed where they're needed. Especially, you know, think about it with the heat maps needed for Wi-Fi or for DAS. You know, you do your heat map study and you find, oh my gosh, you know, I have a dead spot, but I don't have an outlet. What do I do? Well, this allows you to just, you know, run a cable. You could do a hybrid cable, so everything's done under one pole, and then you have power and data delivery to that place, and then you can put in your access point or your radio unit to supply the power to run your wireless network. That's great. So that's one of the great things about it. There's many great things, but that's definitely, it allows you to put components where needed. With digital electricity, they have a pulse packet type of technology. Now, that doesn't have to be a pulse packet power delivery. There's also DC power delivery from other vendors. But you know, I'm describing. They both have this this data link or this talking between the transmitter and receiver. And if anything happens, just cut the cable, I grab it, I change its characteristics somehow, it'll immediately know that and shut down before any damage can be done. So that's where the safety comes from. So every so often, every packet, every given instant, there's always that safety check whenever an energy packet is sent. And then after the receiver, in between the transmitter and the receiver, that's considered the class 4 circuit. And then after the receiver, then you have to go back to whatever you want to do. So it could be a class 2 power supply, it could be an AC, it could be high voltage DC. There's all sorts of these options, and it really depends on what you're trying to do. But at the end, that's where it's no longer class 4. Now you consider it being a different type of circuit under a different set of rules. When I talk about smaller conductors, the graphic that I have here down in the middle is my way to describe it. If I wanted to deliver 100 watts and go 2 kilometers, I can do that with fault managed power with 2-pair 18 gauge cable. If I took that same 2-pair 18 gauge cable, I could do that with DC too as well. But I would have to have a lot of parallel circuits to make that happen, and it's actually 18 times more. Conversely, if I want to do 2 kilowatts, with fault managed power, I can do that, and I can go 100 meters with that same 18 gauge 4 conductor or 2-pair cable. But if I wanted to go 2 kilowatts over 100 meters, again, I could do that with traditional DC. But since I have that limitation of 100 watts per circuit, again, I would need 18 times more, almost 20 times more cables. So that's where the significant or smaller conductors comes in. But the fact that I can go significant distance with that one cable, that's the other S that we have to think about. Up on the top right is installation of fault managed power cables, and I believe this is at the Miami Hard Rock Stadium. And you can see it's using cable trays and installed by RICT integrator. And within the NEC, it's being treated the same as PoE category cables and fiber. So this is my elevator speech, and this is a long elevator, so you really have to focus down on the bottom left. It's the 5 S's if anybody wants to know what fault managed power is. Let's get into some use cases. As I said, we've done this on thousands of venues, over tens of thousands of systems deployed, millions of feet of cabling have been installed since 2016, I guess, is about when we started to see it ramp up. So it's been, I think it was even being used before that. So it's found its place in hospitality. We have use cases on our website on the Circa, the London Underground, so in transportation. It's finding great uses in vertical farming for agriculture, and again the public venues. So this outdoor wireless requirement for DAS, so that we can all keep on our phones while we're at the game and not be stopped because of the other 60,000 people that are in that same stadium. This is allowing that to happen as well. And so we design cables that are optimized for fault managed power with several different gauges and hybrid as well, because these always go with data or in communication systems. So we have hybrid versions, shielded, unshielded, and all of them have the class 4 rating that we obtained from UL, and we helped UL to define that standard as well. All right, so I wanted to dig a little deeper into a specific use case, and this is a little different than what I had in Orlando last year. So I wanted to go a little bit deeper into an optical LAN network. So this is a optical LAN, so I'm going to have an OLT going through a distribution split. That's going to be in my MDF down in the basement, but I'm also going to deliver remote power throughout my building. So in the basement, I have my MDF with my OLT splitting off to several different floors on my hotel, let's say. and I'm going to use my class 4 hybrid cables or my class 4 cable along with distribution cable to do that, and go to each floor, and each floor is going to have an IDF. So I use my DE transmitter in the MDF, and then I have a receiver in the IDF, and that receiver is going to immediately power a DC power source. So this gets it to several different 100-watt circuits that I can go to several different ONTs. And my ONTs, let's say, are in every room. And in every room, I have all my connectivity needed. My ONT has PoE on it. So the end devices are getting data and power delivered straight from my MDF. So this is a way to have everything on one network and have everything centralized. And as we try to remotely monitor all these several buildings, this is the way to go, in my opinion, because now you have one place to check to see when things possibly go wrong, and then be able to deploy the fix from that central location. This is the schematic version. And so I like to go into a little bit more of a layout version. This is using my Visio talents, and they're very poor, but at least it gets the point across. So I have all in my MDF, I have my rack, I have my transmitter at the bottom with my power cables coming up to a panel, and then going through my distribution racks. I have my OLT in the middle with my fiber going to that. So I have power and data going up to my patch panels above that. And that's where I have my options of having separate DE and fiber, which would be the green and the yellow, or I could do a hybrid DE, which would mean just one cable. And that would deliver fault managed power over a longer distance, because I'm taking this to all my different floors. And then at each floor, I have in there my my power supply. This power supply is a unique one because I'm bringing in DE on one side, and then I'm having class 2 coming out on the other side. So within one rack unit, I'm able to have, you know, 2 kilowatts coming in, and then taking that 2 kilowatts into 18 individual circuits, individual 100-watt circuits that I can go to all the different ONTs that I have dispersed around on that floor. And so that, I have to go through my patch panel that I have at the top. And then I have my hybrid cables going across. Again, I could do this with multi-conductor cables and distribution fiber if I wanted to, or I could use a hybrid, but this is where I'm using DC or 100-watt class 2. And then I'm taking it to my adapter where I'm breaking that up. And now I can have patch cords going from my hybrid adapter, which we're calling Duet Connect, and have a fiber patch cord going to my ONT, and then individual power jumpers going to that ONT as well to provide power. And then my ONT has PoE output. So now I'm using category cabling to connect my ONT to my end devices. So just to kind of give you the idea of how all these things go together into an entire solution is what I'm trying to show you here. And I also want to say, one doesn't take precedence over the other. Each one has its place. So all these different power delivery methods, they work together. I guess I'm about on time here. So the key takeaways that I'd like for you to take away from this, obviously, that's why it's called such, is that class 4 fault managed power is just as safe, if not safer, than class 2 limited power supplies. Class 4 cabling is installed the same as class 2 and class 3 cabling, so that puts it in the same pathways and spaces as category cabling. Class 4 cabling has a 450 volt rating, so it's higher than class 2 and 3 cabling, so there's no substitutions. You have to have class 4 cabling for this. And then all the whole system has to be certified, so the cabling, transmitter, and receiver needs to be listed. And if anybody asks you what's fault managed power, remember the 5 S's. And if you need to have more information, please, we have a landing page on this, white papers and such, and I know that IWCS also has several different places to get some more information. So with that, I'd like to turn it over to Dave.
Ron, again, thank you so much for an excellent presentation. That really was a more than an elevator speech. I think really did encapsulate this exciting new opportunity, new innovation, and something that will really benefit society as we look to sustainable energy delivery and on-demand data, power, and that convergence of power and data. So really appreciate how you did that and presented the use cases as well. Um, One question is, can you describe the differences or, the differentiation between fault managed power and power over Ethernet? And, power over Ethernet started back in the mid 90s, I guess, and this is a little bit different. Can you help explain that difference?
Yeah, I'd like to go back to this schematic if I could. So one of the S's is significant power, and the other S is significant distance for fault managed power. So I wouldn't be able to go PoE from my basement up to the 20th floor of my hotel. It's just too far away. We'd have so much loss in the copper cabling that it just wouldn't work. So you'd have to bring in fiber in order to go to every floor. But then you always have the need for power. And if I wanted to keep things centralized, then I would use fault managed power, because then I'd be able to go from the basement all the way up to the 20th floor with that one cable. With PoE, you can, obviously you can deliver power and data, but the reach is limited. We do it's all a lot of I squared R losses because the voltages are lower. So we're looking at more losses in the current due to the resistance of the cabling. Whereas with that fault managed power, we're going beyond that I squared R loss with the higher voltages that are used to distribute that. So that's getting more technical into it, but it's really about power and distance. And if I wanted to go far distance, a lot of power, like I want to go from an MDF to IDF, I would do fault managed power. And then to go to the individual items on the end, where you only need 7 watts or 30 watts typically to each device. I know you can go higher, and we will go higher, but you don't need that. You don't need that big overhead to deliver that power and data that way.
Yeah. Again, to the audience, if you have any questions for Ron, you can enter them in the chat here. We have a few minutes left. Ron, an additional question is, in the delivery of data and power, and the right amount of data and the right amount of power to devices, especially in extended distances, do you see that this would need to be a hybrid cable, 2 cables in the same pathway for both the data and the fault managed power, or do you actually see perhaps data going through some singular cable design with the fault managed power?
Yeah, so we support both, and the cables that you see on this graphic as well describe that. So the yellow one is distribution cable. So that's purely fiber inside, so subunitized. So that can run along to the one the third one down, which is just conductors. So you could have 2 cables in that instance. The green one being your power and the yellow one being your data. But we can take that yellow cable and stick it inside what you can see on the one on the very bottom. I don't know if you can see my cursor, but this one here, has the fiber inside along with the conductor. So this would be what we call a hybrid digital electricity cable. So you could do both, and then you'd have to split it out in some way, and that's what this what we're calling duet connect will do. Even though I'm showing a DC hybrid coming in, you could also bring in DE hybrid to break it out so that you can patch out your fiber and your power to individual end devices.
And the component for the fault managed power would have potentially different size conductors depending upon the device and the distance?
Yes, so the longer distance usually requires larger conductors, and that's the other big difference.
Great. Um, is there, this is an interesting question. Is there a hierarchy to the listings? Does, for example, like in plenum, riser, general purpose, those kind of fire performance requirements, um, is there a hierarchy to these cables? Does class 4 work for a class 3, subsequently class 2? It's an
Yeah.
interesting question.
So you're getting into the substitution tables, which I don't have presented here, but I can talk to it, I think, through this here.
Yeah.
So within the National Electric Code, there is a substitution a table. And that substitution table, if you look at just the plenum versus riser versus the CM, would be something like, plenum can be substituted for riser, and then riser can be substituted for CM. So that's kind of the hierarchy from a fire prevention standpoint. Now, when we think about the cabling part of it, it's a little different. Now, if I have a 300 volt class 3 cable, there is substitution that I can use that for class 2. But I can't use that 300 volt class 3 for a class 4 because we have a 450 volt requirement that's not met. We don't want to take class 2 and have them go backwards to all these unless you really wanted to, but to avoid that confusion of substitution. And since these cables are usually a unique system in itself and also much larger than what's needed for class 2 and 3, the only way that you could use class 4 for these other class 3 or class 2 is to have a dual listed cable like I show here where it's CL4 or CL3. But if it just had CL4, it's only good for CL4. And that's defined in the National Electric Code as well.
Okay. Again, thank you for your questions to the audience. And again, I want to make sure to really send our appreciation to Ron for a very excellent presentation. And again, you'll be able to see a recording again if you want to go back and revisit some of the information. But also, as I mentioned, we also will provide you with Ron's email address. So let me just get this up for you. So hopefully you can see that. So Ron's email address, if you want to reach out directly to Ron and ask him any individual questions or some of the support that he and his Belden team can assist you with. As I mentioned, each of the webinar series events are recorded, so there's a whole history and log of a lot of really good presentations on our website. In the chat, Becky posted the link, but it's very easy to find on our IWCS.org website. Normally takes about a week for them to be uploaded, so by next week you'll have this particular recording available. The IWCS webinar events occur once a month. Our next scheduled technical paper presentation webinar will be on Friday, July 19th at 10:30 a.m. Eastern USA time. Each of you will be receiving an announcement for these events. So please feel free to share them with your colleagues so that they can join and register as well. And with that, it is really important that we recognize the partners with IWCS who contribute greatly to not only the content, but also in their strong leadership and generosity to the success of the Cable and Connectivity Industry Forum. We would not be able to bring these important technical innovations and information to you and our global community without their generosity. So again, thank you to these leading suppliers for their support. And again, we're really excited to be pulling together a really vibrant and exciting program for our conference in October. It will be returning to Providence, Rhode Island. here in the USA. The preliminary program has just been released and it's available on our website. You'll also be seeing various different email blasts to also receive some critical links to consider your participation, registration. And if you're traveling from overseas, please look into receiving any travel letters for your visas. I know these things take time, but anyway, hopefully you'll be inspired from the preliminary program to join us in Providence, Rhode Island. For over 72 years, IWCS has been putting on this conference. And again, we're excited to be in Providence, October 14th to 17th. Please note that the conference this year is Monday to Thursday. We're actually returning. It's the way it was for many years. But last year and several years prior, we were Sunday to Wednesday. But anyway, it's Monday to Thursday for your travel plans. So with that, we thank you for participating today. We hope you have a great weekend and look forward to being with you again soon. All the best. Thank you.